Hi guys, welcome back to the channel. Today we are going to start with the topic matrices unit 1. Matrices. SAQs we are going to start short answer questions. That is for 2 marks. So first question is find the rank of the matrix. Matrix is given as in the question. A is equal to 1 minus 0, 6, 3, 6, 1, minus 5, 1, 3. First, you have to write the row 1 as same, minus 1, 0, 6. You have to change the R2 value as R2 minus 3R1. So we have to make this row 0. Then you need to make the another row 0. R3 is equal to, you need to add minus and minus gets added, so we need to subtract it again. So we use R3 minus 5R1. So 3 minus 3 plus 3, you take R1 as 3 and multiply with minus 1. It becomes 3 minus 3 as 0. Now 6 minus 0 is 6. 1 plus 18 is 19. Now R3 minus 5R1. So R3 is minus 5. Minus 5, R1 value is minus 1. So it becomes minus 5 plus 5, it becomes 0. Now 1 minus 5. Now 3 minus 5 into 6. So it's 30. 30 minus 3 is 28. Sorry, 27. 20. So now we need to make this element 0. So R3 is equal to 6R3 minus R2. First we have to use R1 in both the equations to solve to make these elements as 0. Now we need to make this element 0. So A is equal to 1, 6, 0, 6, 19. Now this element has become 0. Now we need to move this, next to you need to move to this element to make it 0. So you use 6 into 1 is 6 minus 6, it's 0. Now 27 into 6. 27 into 6. It's 42. 6 2s are 12. 13, 14, 15, 16. Minus R2 value is 19. If you subtract this both, it's 143. So the zeros are increasing as you move next row. Row 1 has non-zero element, then row 2 has 1 0 element, then the row 3 has 2 0 elements. So as you go next to the rows, as you move going on to the rows, so the zeros are also increasing. Then the rank is equal to non-zero rows. As the non-zero rows are, A is equal to 1432. So to find the eigenvalue, you need to use the characteristic equation, that is A minus lambda I is equal to 0. So A minus lambda I becomes 1 minus lambda 4 3 2 minus lambda. As minus lambda is multiplied to the diagonal elements only, as I means 1 0 0 1. So if you multiply with lambda to this equation, it becomes lambda and this becomes lambda. When you again multiply, you need to now subtract it with A minus lambda. So it becomes this. as you need to multiply AD minus BC. So 1 minus lambda, 2 minus lambda minus 12. Now 2 minus lambda minus 2 lambda plus lambda square minus 12. Now lambda square minus 3 lambda minus 10. Now we have to find out the values of lambda. So 5 2s are 10, minus 5 lambda plus 2 lambda minus 10. Lambda is taken as common. Lambda minus 5 plus 2 is taken as common. Lambda minus 5. So lambda plus 2, lambda minus 5. Lambda is equals to minus 2, lambda is equals to 5. So we have find out the lambda value and eigenvalues of the matrix. These are the two eigenvalues. Third question is find the sum and the product of the eigenvalues of the matrix, as the matrix is given as 2 2 1 1 3 1 and 1 2 2. So sum of the eigenvalues has the property that sum is equal to trace of diagonal elements of the matrix. Diagonal elements means these are the diagonal elements. Product of the eigenvalues is equal to that of the matrix, as we will consider it as A. So sum is trace of the diagonal elements means adding this diagonal elements, 2 plus 3 plus 2, so it's 7. Now product that of A means 2, 3 2s are 6 minus 2 minus 2, 2 minus 1 plus 1, 2 minus 3, 6 minus 2 is 4, 2 1 plus 1 minus 1. Now 4 2s are 8 minus 2 minus 1, so it will become 8 minus 3, as it's 5. So product of the eigenvalues is 5 and sum of the eigenvalues is 7. Now moving to the fourth question. Fourth question is show that the vectors 1 2 3, 2 3 4 and 0 0 1 and 3 4 5 are linearly independent. So we need to prove it that it's linearly independent or not. So first we will write in the form of matrix 1 2 3 2 3 4 0 0 1 and 3 4 5. Now we will solve it as how we solve it as a form of rank. So R2 is equal to R2 minus 2R1, as R3 is having 0, so we don't use this equation. R3 for the R3 we don't use, for the R4 we use it as R4 minus 3R1. A is equal to 1 2 3, 2 minus 2 is 0. Now 3 minus 4 is minus 1, 4 minus 6 is minus 2, 0 0 1, 3 minus 3 is 0, 3 minus 6 is minus 3, sorry, it's 4 minus 6. 4 minus 6 is minus 2. 5 minus 6 is minus 1. Now you need to make this element as 0. So R4 gives R4 minus 2R2. A is equal to 1 2 3 0 minus 2 minus 1 minus 2 0 0 1 and 0 minus 2 and plus 2 becomes 0, minus 1 and plus 4, minus 1 as R4 as and minus of minus 2. So it becomes 1 minus 1 plus 4, it becomes 3. So here I have to write minus 4 as 5 minus 9 is minus 4. So first we will divide this R4 divided by 2. So it gives minus 1 minus 2. Now A is equal to, we will subtract these two rows. R4 gives R4 minus R2. So 1 2 3 0 minus 1 minus 2 0 0 1 and this row becomes 0. Now we will write it in the form of equation as x plus 2y plus 3z is equal to 0 minus y minus 2z is equal to 0 and this last row is written as z is equal to 0. Now we will substitute this in the equation, this equation as minus y, this becomes 0, so y is also 0. If you substitute in first equation, you will get as x is also 0. So x is 0, y is 0, then z is also 0. Then it is said to be as linearly independent. If these all are not 0, then we say that it is linearly dependent. Solving next question. Fifth question is find the value of k such that the rank of A is 1 minus 2 3 2 k 4 minus 2 minus 1 2 5. This is the matrix given is 2. So the rank of A is 2. So the rank of A is 2 means you need to find the rank of A is means R minus 1. As you need to find the det of A. So 1 5k minus 8 plus 2 plus 2, then 5 to the 10 plus 4 plus 3 4 plus k is equal to 0, or we don't take is equal to 0. So 5k minus 8, 14 plus 2 is 28, 12 plus 3k, 8k, this becomes 20 plus 20 plus 12. Now it becomes 8k plus 32. 8k is equal to minus 32, k is equals to minus 4. So we got the value of minus 4. Sixth question is find the rank of the matrix. So we have solved this type of question. As you use row 2 to R2 minus R1 and R3 is equal to 2R3 minus 5R1. Now 2 minus 1 3 1, it becomes 0 as 2 minus 2 is 0. Now 4 2s are 8, 8 minus of minus 1 is plus 1, it becomes 9. Minus 4 minus 3 is minus 7, and 2 minus 1 is 1. This 5 10 minus 10 is 0. Now 4 minus of minus 5 is plus 5, so it becomes 9. Now 4 4 to the 8, so it becomes 8 minus 5 3 the 15. Now it becomes 8 minus 15. This is minus 7. This is 1. Now we'll solve R3 as R3 minus R2. So this becomes 2 minus 3 minus 1 3 1 0 9 minus 7 1, and this becomes 0 as 3 minus 2 3 minus 2 3 minus 2, so 0 0 0. So the rank is the non-zero rows as it's 2, so the rank is 2. Done with this question. Solving the 7th question, that if a is equal to minus 1 2 0 1, find the eigenvalues of this equation. You need to make as a to the power 3 plus 7a square plus 2a. So a cube can be written as a square into a. So now first we need to find a square. A square is equal to a into a, that is minus 1 2 0 1 into minus 1 2 0 1. So we need to multiply it as row into column. So minus 1 into minus 1 is 1, 2 into 0 is 0, so I'm not going to write the 0. Now we need to multiply, as I'm not going to write 0 here. Now we need to multiply. Minus 2 into 2 is minus 2, and this becomes plus 2 as this becomes 0, and 0 into minus 1 is 0, and 1 into 0 is 0, so I will write here 0. Now we need to write 2 into 0 is 0 plus 1, so it becomes 1. A square is 1 0 0 1. Now we need to multiply a cube as a square into a, so a square is 1 0 0 1, and a is minus 1 2 0 1. You need to again multiply this row into column. Minus 1, and it becomes 2 0 1. This is a cube. Now you need to add a cube 7a square then 2a. So I will write a cube value as minus 1 2 0 1. 7a square I am writing it as direct value by multiplying 7 here. So 7 0 0 7, then 2a. I am multiplying 2a directly as multiplying 2 here. It becomes minus 2 4 0 2. Now adding this, it becomes minus 1 plus 7 minus 2, so 7 minus 3, it becomes 4. Then 2 plus 2 plus 4, it becomes 6, here 0, 7 8 9 10, and here it becomes 10. Now you need to find the eigenvalues of this matrix as A minus lambda I is equal to 0. This is characteristic equation. Four, 6, 0, 10. So after lambda minus I, it becomes minus lambda and minus lambda in the diagonal elements. Now we need to multiply 4 minus lambda and 10 minus lambda, as this becomes 0. So I am not going to write it here as plus 0. So it becomes 40 minus 4 lambda. Now minus 10 lambda, then plus lambda square is equal to 0. So lambda square minus 14 lambda plus 40. You can solve this in the calculator or manual method. Four into 10. So lambda square minus 4 lambda minus 10 lambda plus 40 is equals to 0. So lambda will take common, lambda minus 4, 10 common, lambda minus 4. So lambda minus 10, lambda minus 4 is equal to 0. So lambda is equal to 10, lambda is equal to 4. We got the two eigenvalues of the equation